So we have Brett Henning from Broadcom and Austin Bolen from Dell. They're going to talk about eSFI and PCIe MI. So,
yeah, thanks, Brian. Yeah, Brett Henning from Broadcom, and yeah, we're actually here speaking about something that's not SPDM, so thought that'd be a nice change of pace. Yeah, so we're going to be talking about eSFI and PCIe MI, and specifically talking about use cases that are relevant to people designing security for systems. If you're interested, Austin will also be having another talk in about 45 minutes that will go into some of the more management-focused aspects. As I go through this, we're probably both going to do some blending of eSFI and PCIe MI. So, even though they came into the PCI standard as separate ECNs or published as separate ECNs, in a lot of ways there's coupling, and it's really eSFI provides some knobs and some manageability control points, and PCIe MI provides kind of the spec-intended mechanism to go and manipulate those control points. Kind of drilling into a little bit more, what eSFI gives you is it gives the external management entity control over the PCIe links and behavior on the links, and then a lot of associated things that you would need related to that. PCIe MI then is a set of commands focused on managing those control points and really just managing config space. So both config space read and write. So okay, yeah, getting into what is in eSFI. So eSFI takes takes the existing SFI and extends it. It really takes a lot of the stuff that was in SFI and makes it something that's enforceable. So yeah, and then the big thing that's added to it is quarantine mode. So quarantine mode actually lets the system manager control when links come up. So you can actually power on devices with links down, and then manage when devices actually get pulled into the system. This also has a really handy aspect for hot plug, because hot plug is always kind of dangerous in a security context. So now you can control actually taking devices and holding them offline when they're hot plugged into the system. And then there's some really interesting things with filtering. And I know Austin's going to go into that more in a second, but you can, even when you bring up the links to the device to take them out of the quarantine mode, you can still filter the traffic that's going to them. So you can basically go from devices offline to devices online, but very limited in what they can do, and then fully online. This is just a quick example. This is out of the PMCI white paper, but this just gets into how all the different or all the different protocols stack up in PMCI. PCIe MI is just a traditional application layer that sits on top of all of the existing work in MCTP. So it sits on top of MCTP, and therefore it can leverage all the different bindings. So it can work through traditional out-of-band interfaces. It can also work with the traditional in-band interfaces. So what's in that command set? The command set, of course, has discovery, so you can discover what is supported on the device. And then you can figure out where the ports are, so you can actually find the different ports that all get to the same piece of silicon, because a lot of times there are 2, 3, 4 ways into the same piece of silicon. You can actually make some sense of that. And then very important thing there is read and write of config space. So this lets you really take a lot of things that were traditionally done in band and shift them out to other management entities, primarily a BMC. There's also a lot of other kind of more advanced commands with things like changing connector configurations, managing the routing information. If you kind of read into that and squint, you'll start seeing things that relate to composability in there. And then I'm going to hand it over to Austin to go through an example flow.
All right, thank you, Brett. Yeah, so I just want to walk through an example of how you can use these technologies to do PCI Express security quarantine. So in this example, it's very similar to if you've seen the split reset sequence in the OCP attestation spec. So they define this model where the server can be brought up out of reset and powered on, but the PCI Express components are still held in reset using the PCI reset signal. And while they're in reset, the BMC can go sideband and perform SPDM authentication of those components. And then once they're successfully authenticated, then the platform can release PERST and expose those devices to the system. One of the challenges here is, like, since you're holding PERST to the endpoint device you're testing, if it's a malicious device, it may simply choose to ignore that signal and bring itself up and try to inject traffic into the system. Additionally, some devices may not have a sideband bus that would be needed in order to do this. So if they didn't have that sideband bus or it was too slow, you wouldn't be able to use that mechanism. And eSFI adds in support to address some of these things. So for example, the control plane here is moved from the device up into the port above the component. And that's what's actually holding the device in quarantine. So if you did have a malicious device, there would be no way for itself to get itself out of this quarantine mode. I would just also note here that this flow is talking about on system boot up, when you initially boot up. But a BMC can use a similar kind of flow to keep a device hidden from the operating system whenever you hot insert a device, and so it can keep it hidden, authenticate it, and then expose it to the host. Okay, so we have an example server system here. It's got host CPU and root complex. It's got a switch connected to it, and it's got several endpoint devices connected to it. And it's got a BMC with sideband buses connected to all the different components. And when you first power on the system, there's a way in eSFI where you can take all these PCI Express downstream ports, so the root ports or switch downstream ports, and you can have them come up in this quarantine mode by default. So when they're in this quarantine mode, the links are disabled, so no traffic can flow to or from the device, and the presence detect state to the in-band host is masked out so they don't see any device there. But the BMC can still see the devices via the sideband channel here. So when you power up the system, one of the first things the BMC may want to do is to go into the host CPU root complex via some sideband channel and authenticate it using SPDM over MCTP. And assuming that it was authenticated successfully, you may want to have your BMC then go and authenticate all the other components that are connected to the root complex, so any of the switches or endpoint devices. In this case, we're showing it using a sideband bus to do that, but if you don't have a sideband bus or the sideband bus is too slow, eSFI provides an alternate mechanism where you can bring the PCI links up, but they're in a very limited state where the only traffic allowed is PCI VDMs between the BMC and the endpoint device. So that way the BMC could do the SPDM authentication over the main PCI bus while keeping the component still isolated from the rest of the system. Yeah, one other thing I would note here is that in addition to authentication, at this point where the devices are still in this quarantine mode, you can do any number of other configuration operations. So if the firmware on the component was corrupt, you could use the OCP Secure Firmware Recovery to recover from that. If it didn't have a flash chip for the firmware, you could do the OCP flashless or streaming firmware update or any number of other configuration tasks. So in this example, we're going to assume that the All the components are successfully authenticated, except for component B, which fails authentication. So at this point, it's kind of platform policy. What you may want to do, you may want to just halt the system and report the error to the user. In this case, we're going to carry on, and we're going to have the BMC go and clear the quarantine mode, but only in the ports above the devices that were successfully authenticated. It's going to do that by issuing PCIe MI over MCTP commands to the SFI registers in all of those ports. And when it does that to clear the quarantine mode, the PCI links will be enabled, the presence detect state will be unmasked, and then the system can gain access to those devices as normal. And now in this scenario, remember component B failed its authentication. So in this case, we're just going to leave that port quarantined so it can't cause the system any harm, and we'll notify the user of the issue so that they can take care of it. Okay, and with that, yeah, just call to action. I mean, please have a look at these technologies. There's links to the ECNs for these two technologies. Both of those have been incorporated into the PCI base spec version 6.4 and later. There's a link to a PCI SIG DevCon presentation with a bit more detail as well. We'll just note that all of these presentations require a PCI SIG membership to access. We're also looking to add support for these technologies in new systems, so particularly in PCI root complexes and switches and server BMCs. Always please be lookout on, we're interested in any new use cases for this. I mean, we talked about the kind of split reset sequence attestation model. There's the OCP streaming boot. There's hot plug use cases, and could be many more as well. And finally, we'll be looking to add guidance for these technologies into the OCP attestation spec as like an alternate way to do the split reset sequence attestation. And with that, thank you.
Thanks for the presentation. I had a question about the no sideband scenario. In the case where there is no sideband to the PCI device, you said PCI VDMs can be used via the BMC. Would it be type 6, MCTP type 6 that is used, or does it have to be encrypted?
You can use any type of MCTP traffic you want, and if you did support type 6 for the secure encrypted sessions, you could do that, but it's not mandatory.
It's not mandatory, okay. But it has to be PCI VDMs from the BMC?
In that case, yes.
Okay, thanks.
Yep.
Hi, thanks for the presentation. I'm really excited about this one. If you could go to that authenticated devices slide, I'm wondering, how does the BMC know the topology in terms of saying, I need to authenticate this device before I lift the upstream device out of quarantine and walk through that?
Yeah, good question. That's kind of outside the scope of the specs. So typically, at least the way that we do it in our servers, is that we have our BIOS run, and it has tables about all the specific layout of the PCI topology. And then when we boot up, the BIOS actually sends that over to the BMC so that the BMC knows the topology. But that's just one way. There probably could be other ways as well.
Okay, so in this case, then the BIOS and the BMC would have to have a mapping of basically the PCIe topology to the MCTP topology.
Right, that's right.
And there is some discoverability within PCIe MI. Not the topology piece, but at least enough identifying information to match it with your map.
Okay, thank you.
Okay, I don't think there's any more questions. I had one. Is this tied to a specific PCIe gen specification? Gen 6, Gen 5?
The ECNs were incorporated into the 6.4 specification, but the way the ECNs work is when they're ratified in PCI Express, if you did want to backport those to, say, a Gen 5 switch or root complex, that is allowed. Yeah.
Awesome. Thank you.
Yep. Thank you.
Yeah, great talk. Thanks.
Thanks.